projects. In this video, we are going to explain about a project titled Rumors Detection based on the lifelong machine learning. Weibo stands as a prominent platform where users share and access the information, contributing to an immense daily influx of messages. Tackling the timely contaminant of rumor propagation in this virtual sphere holds the paramount importance, curbing the potential harm inflicted on the public and the nurturing a healthier online ecosystem. This thrust towards the rumor detection carries the profound implications, especially in the realm of social media like Viber. While providing the methods for detecting the rumors encompass both the conventional machine learning and the advanced deep learning techniques, certain shortcomings loom, notably the demand for the extensive training data and the lack of adaptability for ongoing knowledge refinement. In response, we introduce a pioneering approach rooted in the lifelong machine learning, embracing the essence of continuous learning and cumulative knowledge acquisition. And this framework, our project revolves around introducing an innovative strategy for constructing a rumor detection system harnessing the power of the lifelong machine learning principles. Our model is meticulously trained for optimizing its efficacy, underscored by the reduction of average prediction loss across a spectrum of tasks. The crux lies in our objective function, thoughtfully infused with both the L1 and L2 norms. These norms act as the controls facilitating the seamless transfer of knowledge as we embark on learning the new tasks and progressively enhancing our reservoir of knowledge over the time. And these are the basic requirements that are needed to build this project. Software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7, Jupyter. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. And the first one is importing the package. Here we need to import the essential Python libraries such as NumPy, Pandas, sklearn, matplotlib, and the cbun. These libraries provide the tools for the data manipulation, visualization, and the machine learning. And the second one is loading the dataset. Here we need to load the dataset containing the information relevant to the tumors, and this dataset will serve as a foundation for building and training our rumor detection model. And the third one is data processing. Here, we process the loading data, addressing the missing value, duplicates, and ensuring the data uniformity. Data pre-processing is crucial for accurate model training. And the next one is visualizing using the cbun and the matplotlib. Create the visualization to gain the insight into the dataset, and utilize the cbun and the matplotlib to generate the graph, histogram, and the plot that help reveal the pattern and the trends within the data. And the next one is tokenization. Here, transform the testable data into the numerical representation by tokenizing the text. Technique like word-to-vector and TF-IDF we employ to convert the word into the vectors. And the next one is feature selection. Selecting the relevant features from the tokenized data to train the model. Feature selection enhances the model performance by focusing on the most influential attribute. And the next one is splitting the data to the train and the test. Dividing the dataset into the training and the testing subset, the training data is used to teach the model while the testing data evaluates its performance. And the next step is building the model. Here various models are built, and the first one is BERT-GCM. The combining of bidirectional encoder representation from the transformer and the graph convolutional network. This model taps into both contextual language of reading and the graph-based relationship. And the next one is BERT-GCM plus LSTM plus ENV. It is extension of the previous model. This architecture incorporates the long short-term memory and the convolutional neural network. It captures the sequential dependency in the testable data, while the CNN excels in recognizing the local pattern. This amalgamation ensures the comprehensive feature extraction, benefiting the rumor detection in the complex context. And the next one is GCN, bidirectional LSTM and BERT GCN. Here the hybrid model introduced the bidirectional LSTM layer to the BERT GCN framework by processing the test in both the forward and the backward direction. It captured the contextual norms more effectively integrated with BERT GCN. It accommodates both the global semantics and the sequential context, amplifying the rumor detection accuracy. And the next one is LSTM. A standalone long short-term memory model is explored. It adapts at learning sequential dependency, making it suitable for rumor detection tasks where the contextual understanding over time is crucial. And the next one is RVNN. Recursive Neural Network is a specialized architecture for the three structured data. It's applied to capture the hierarchical relationship among the words in the sentence, augmenting the rumor detection by considering the sentence structure and the connections. And the next one is LSTM plus GRU. Here the combination levels both the LSTM and the GRU units, which are the variant of recurrent neural network. GRU offers efficiency in training and captures the short-term dependency. LSTM here the long-term memory complements GRU, potentially enhancing the rumor detection through a snitching of the memory capability. And the next one is naive-Bayes. It is a probabilistic algorithm and despite its simplicity, it is efficient for the test classification task. It serves as a baseline model to gauge the performance of the more complex approaches. And the next one is decision tree. It is an initiative model that partitions the data based on the feature values. They are easily interpretable and capture the non-linear relationship, and the decision tree offers the transparency and aid in understanding the underlying factors contributing to the rumor classification. And the next one is SVM RBF. Support vector mission with the radial basis function kernel is a powerful classifier suitable for the high-dimensional data. It captures the complex decision boundary and be effective for distinguishing the rumor from the non-rumors in this project. And the next one is SPM-TK. Support vector mission with the text kernel. It's a customized for test data. It leverages the kernel function specifically designed for the testable information, potentially enhancing the rumor detection by accounting for the semantic similarity. And the next one is voting classifier. Here, this is an ensemble approach, combine the prediction for random forest, logistic regression, and the decision tree. Ensemble model tend to improve the overall performance by aggregating the strength of multiple classifiers. And the next one is user input. User inputs the rumor-related task as a query into the system, initiating the rumor detection process. The given input is translated and pre-processed for prediction. Translate and pre-process the user input to ensure the compatibility with the model requirement. And the next one is trained model is used for the prediction. Utilize a selected pre-processed model to predict the presence of rumor based on the pre-processed user input. And the last one is final outcome is displayed. Present the prediction outcome to the user indicating whether the input is likely to be rumor or not. This information helps the user to make the informed decision about the authenticity of the provided information. And for the execution of the project, we need to open the code folder. And this is the code folder containing of various files within it. The static folder containing of folders like CSS, JavaScript, font, images, and web fonts within it. And the template folder typically include of HTML documents like form, index, results, sign-in, and sign-up pages within it. And sign-up is a database file that will be used to store the user information. An app is an py file which contains the information related to the front-end logic. It includes the code written in Python that handle the server-side operation, such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And for the execution of the project, first we need to copy this code folder part and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder part, and by this it will change the current directory to the code folder path. And then click on the enter button. Here we need to write a command that is python space app.p1. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues. And then click on the enter button. After running this app.py file, the class framework will host the application locally at the default address like this. We need to copy this local link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here will redirect it to this page containing of some details within it. And I'm clicking on the sign up button. Here it will redirect to the sign up page containing of some necessary details that I need to be filled. Create an account, but my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of username and password. And I'm entering those details as and click on the login button. Here it will redirect it to this page containing of a dialog box where we need to enter our message. And I'm entering the message as of coronavirus is an exposure of all the holes and the social safety net. Sales by NELP Government Affairs Director. And then click on the print button. And here given the result as of the test as rumor for the given Weibo comment, and it brings the probability as of 99.9%. And then click on the back button, and here at the Weibo button, here we can re-enter the other data. And here by clicking on the Twitter button, in this also we can enter the message as of New August Encounter empty supermarket shelves sold out online grocers as coronavirus fearing the shopkeepers stock up. And then click on the predict button. And here it gives the result as of the given tweet is rumor, and the probability of the model is of 40%. And this way we can detect the message as a rumor or not by using the Weibo and the Twitter. And in conclusion, this model achieved superior Weibo rumor detection results even with the less training data for each task. We extracted the three types of features of content, users, and propagation from the Weibo source content, comments, and repost, and merged them with the bird semantic feature of the original message to form the feature vector. And this model, with the knowledge refined over time, could effectively learn the task even in the case of less training data for the each task. This suggests that there is still considerable room to improve the effectiveness of the rumor detection method, and the future work can focus on early detection of rumors and the cross-language model to platform as a rumor detection model.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.